Hello everyone, welcome to week 13 live class. We are going to be looking at the combination of this week and next week classes, as we are not going to have classes next week. Today we are going to look at functions, and then we'll look at how to get user input. Then we'll go over to look at object-oriented programming in Python. This will combine all the topics for this week's lesson and also for next week's lesson. We are going to look at this at detail level. In the pre-recorded videos, we just have elementary or basic definitions and introductions to this topic. So you need to watch your pre-recorded videos to get the basic introduction, while I'll give you a high-level explanation of those topics. So let's look at functions first. Before we go to function, we have a global that we call name, written like this in Python. We are going to be looking at all of these magic methods, or what we call dunder method. When we say dunder method in Python, it means you have a double underscore, then you have the name of the method, and then a double underscore like this. These are magic method or dunder methods, and they run based on different conditions. When you have like init, it runs once a script is run or initialized without you having to do anything special. But for this name, when we want to run a script, we set name equal to main, which is always what Python does. So you find in most Python scripts, you have something written at the bottom, like if name equal to main, you want to do something here. And we don't know what we want to do yet, so we'll use pass. We always use pass in Python as a placeholder so that that file will not error out. So when we define a function, a method, a class, we can just put pass in the body of the definition as a placeholder, so we don't have errors while we create a skeletal code for us to know what it is that we want to write there. So it's always if name equal to main, a colon, and then you define what you want it to do when you run the script. So this is always to run the script. So you can think of this as a way to store code that should only run when the file is executed as a script. So this global name is set to main by Python if the interpreter runs the code, and we're going to use this to run all the code that we're going to write above it once we do. So you can either do this, or without this, just click on your run button to do that. But when you write your script, you always have this at the bottom to always run, to write what to do, to test out the code, to test out your functions. You test it out at the bottom of this. All right, so we have looked at functions in a basic form in the pre-recorded videos. We now want to look at these functions in greater details, and we want to see how we can write production-ready code. And we want our functions, when defined, to be functions that can be used in production for a final software development. A function is defined in Python using the def keyword like this, and then we have a name for the function. The function names, we can always write them in lowercase, in camel case. Let's say we want to have a function called greet, and then we have a pair of parentheses, a colon, and then we will write what we want the function to do. This one we want it to return, and we want to say it should return hello and welcome. Okay, in Python we use print statements to print things to the screen, but when you are creating or writing your code, the function returns something to the calling script, and we use return and not print when you develop your statement. Print is always for testing. We don't use print statements when we're actually developing our software. So we start learning this in production-ready way, where we define our function and we use a return statement. And when we want to call this function in the body of this, we can now say print, just to test, and we're printing greet. Okay, so I'll go over this again. In Python, we define a function using the def keyword, and then a name for the function and a pair of parentheses. These parentheses can take something we call parameters, or it can be left empty without taking parameters. We do something after the colon. That's the function that the function is supposed to do. So the activity of the function is defined in the body of the function definition. At the end of it, we use a return statement to return a value to the calling script. So if we are creating a function to add two numbers together, we want to return the sum of the numbers. So things like that. So this is just a basic function that when called, it just prints hello and welcome to the screen. And so when I save this and I run, we have hello and welcome to Life24 Pi module, just like we want it to print. So we test here in the body of the if name equal to main. I'm written down there. Is there any question? So the return statement will return a value to the calling script when the called function finish or complete its tasks. Now, we talked about this having parameters and leaving it empty. In Python, when you define a function, let's say for instance, we want a function called addition, and we want it to add just two numbers that will be supplied as arguments. These A and B are called parameters. We write them as comma separated list. What we want this to return now is the sum of A and B, so we'll say return A plus B. So when we come here and we call the function addition in the print statement, so we'll not use print yet, we'll just call the function. So we'll say what we want it to do here is to say addition. So you call the function by specifying the function name, and in the parentheses, when you have parameters in the definition, you want to supply it with arguments. So let's say what we want to add is 2 and 3. So you supply it here because this has A and B as placeholders. And when you say print this, let's print this, it is going to now give us 5, because what the function is asked to do is to take two arguments, A and B, and return the sum of those two. And when I save this and I run, I'm going to get 5 printed because the function does or executes a task. So the purpose of a function is to have something that executes tasks. So instead of repeating that task all over again, you have a helper function that you have created that anytime you want to do a particular task, you call that function and it executes the task without you having to write those codes over and over again. Is there any question? Okay. So we have two types of arguments, and when we call a function like this, what we just did now is called positional arguments, and we must include this in the order in which they are defined. Now, this addition does not really show the kind of error you will have if you put this in a different order, B before A. But if we have something that has to do with something that computes a more complex kind of arithmetic, then you begin to see where positional arguments begins to fail if they are not specified in the order in which they were created or stated. Any question? Okay, so let's illustrate the types of arguments we have. We have positional arguments, and then we have something we call keyword arguments. And we're going to illustrate this using different types of functions that we'll try to create as we go along now. Now, when we talk about positional arguments, it's something that you must specify in the order in which the parameters are specified. But when we say keyword arguments, you use keyword to name those arguments or the parameters so that whichever order you specify them in, when you use a keyword, it's not going to have that effect of having errors if you have the kind of computation that needs them in a particular order. So we're going to create a new function. Let's say we want to create a function that maybe calculates the area of a trapezoid or something like that, and we'll look for the formula of those kind of functions that will allow us to be able to illustrate the effects of positional and keyword arguments. Now we'll delete this, and we say that we create a function using the def keyword and then a name for the function. So we want to get something that we call the area of a trapezoid. So we'll say area trap. Let's do it like this. And in the pair of parentheses, we want to supply arguments. We need 3 arguments or 3 parameters for this, because the formula for the area of a trapezoid is a plus b over 2 times height. Let's put it as a comment here. So the formula here is, we want it to calculate a plus b. So we have a trapezoid has 2 bases, the top base and the bottom base, right? Times height over 2. So this is the formula. So you can actually put the stuff in parentheses. Sorry, this is going to be over 2 times height. So you can put it in parentheses to say you want this evaluated first. And when we look at the order of precedence, we'll know how to get this done. So the formula for this is a plus b over 2 times height. Is the formula to get the area of a trapezoid. We have a top base, we can call a, bottom base we call b, and then we have the height of that. And so we know this formula like this. We want to create a function that is going to return the value based on this formula, which means that we need 3 parameters, which is the a, the b, and the height. So we'll say a, b, h as the parameters, and we want it to return a plus b over 2 times h as the value. So anytime we have a trapezoid, we can just put the values of the bases as a and b, and then the value of the height, and then we can print area of a trapezoid whose bases are 2 and 3, and the height is 5. We should get 12.5, I think. And when I run this, we have 12.5. Now this uses positional arguments, and we're going to have a problem the moment we begin to switch. Let's say we want the height to come first and we want the second base to come last. So it will give us a different value, because positional argument means that they must occur. You must specify this value, this argument, in the order in which they are defined in the function definition. And so when I do this now, I'll print this out and I'll get 8.0, which now makes it wrong. And this is what brings us to keyword argument. Because we have a, b, and h, instead of having this problem, we want to specify h is equal to 5, a is equal to 2, b is equal to 3. So now it will not matter the order in which they are specified anymore if you use keyword arguments. Keyword argument means that the name of the argument here, you specify and put a value. So it knows that, okay, this is for h. Even if you put it first, it is for h. It's going to be evaluated for h. And when we run this, we should get 12.5, which is supposed to be the answer, because now we use keyword arguments and the order of specifying the argument now no longer matters. Is there any question? Okay, when we define functions, we have 2 special symbols that we call args and keyword args. Now we use these 2 symbols to pass arguments in Python, and both of them we use a wildcard called the asterisk like this. And we use this for the args when we do not know in advance how many arguments that the user is going to specify. And we use double asterisk and the keyword args if we don't know how many keyword arguments the user is going to specify. So let's do an example to illustrate the args and the keyword args. Let's say we want to create a function that takes 2 parameters, and one will be, let's say we want to make a statement with family names, for instance. So we'll say def, let's say fam names or family members. Now we're using this to list family members of people. Maybe we're developing an app and we don't know in advance how many members of the family anybody have or anybody has. We want to have a first argument, which will be that they should specify the last name, and a second argument, which will be specify a list of all the members of the family. Because we don't know how many they'll specify, we want to use the args symbol. So the first one will be, let's say we have it called last name, and the second one will be asterisk, and we'll have names. You can even have args if you want, or you want to have names. Args is just the conventional that we use to specify several arguments if we don't know the number of arguments that the user will supply. So we said specify the last name and then a list of all the family members that exist in that family like this. And what we want to return now is, for instance, we want to say return last name, names. Let's just do this for illustration, then we'll look at how we can print them out better. And now we'll print out fam members, and then we'll put the first argument is the last name and the rest of them are the members. So we can actually return a statement that makes it even better to read or to illustrate this. So we can say, let's use the format method. We'll say family, whatever the last name is, has the total number of members. That will be the length of the name specified here. And so when we come here and we do fam members and we call this, it will count the total number of members that this has. So if all is well, we should have, this has 3 members. So we have family Smith has 3 members because Smith is the last name. It's on the last name position, and we put names to specify any number that we want. If we come here to add more members here, to say we have Bob, we have Eve. When I run this again, it has 5 members. So when you use the asterisk sign before the name of a parameter here, it means that the user can supply any number of arguments. We don't know in advance what this is, so this is what we do, and this is what we use mostly in our software development, where you want people to list certain things, or depending on the app you are developing, maybe a school app, you want them to list the students in a particular class, and there'll be different students in each class. So we don't know in advance how many it will be. So we'll make this dynamic by specifying it this way, and then they'll be able to specify any number. And then want it to return maybe a statement, or we want it to do something, send them to the database, or we want it to create a file for 5 people because there are 5 members of the family, or anything like that, depending on the requirements of the system we are developing. So we can do the same thing, but now we want to use keyword arguments. We don't know the number of keyword arguments that the user is going to specify in advance. And this is it's not complicated, but it can easily get confusing. So let's say we want to have keyword args, for instance. Let's change this to keyword args. I want to just change the name of the function. And here we want to say, I'll put 2 asterisk and I'll put keyword args has the parameter. We don't know in advance how many keyword arguments the user is going to supply. So let's say we want to print out all of the keyword specified and their values. So we'll do for key value in keyword args items, we want to print them out like this. Let's print out, or let's say return, so we can print. So we're going to be printing fam members keyword args. So we want to have a keyword arg of name is John and age is 33. If we print another one, fam members, let's say we have first name, we'll put Jane. We have family name, we have Doe. Then we have something like gender. Then we have, let's say, intersex. Okay, so now we have 2 examples where we have the first example having 2 keyword argument, name and age, and the second example having 2 keyword argument, first name, family name, gender. We use double asterisk and the name for the parameter. By convention, we just use keyword args like this, or you can put any name you want. You can just say names or something to specify a placeholder or a parameter where we do not know the number of keyword arguments the user is going to supply. We are just going to loop through what is supplied and get the name of the keyword argument and the value it has like this. And if all is well, you should say name is John, first name is Jane. So we just loop through these two to return key and value. So we can even say print, so it's just loop through and print, but we just loop through the first item here. So we can just change this to say return, let's say keyword args, let's say the keyword argument that it returns. So we run and we'll see name John, age 33, first name Jane, family name Doe, gender intersex. It returns all of this as a dictionary. So you have to practice this to understand args and keyword args. You always find them, you see them a lot. Most of the time in software development, this is what you see more than having default parameters, and we create helper functions that we want to use to do different things, and we don't know in advance what number of arguments we'll have, especially when we are retrieving information from the database or it requires user input. We will not know in advance what it is that the user is going to supply. Okay. Any question?
No question.
Okay, so we can look at user input and how to get user input. And in Python, to get a user input, we just use, for instance, let's say I want to have something like first name is equal to, I'll use the input function, enter your first name. And when let me delete all of this and put pass here. And when I run this, it will ask me enter your first name, and then I type my first name, and that is all. We can now use this input to say print, and then we'll put format string. The first name you entered is first name, like this. And when I save this and I run, I'll get please enter your first name. When I enter it, it will tell me the first name you entered is Mildred, printed out to the page. So this is how we collect user input. We are going to look in details at this. If you watch your pre-recorded videos, you are going to see how we use this in more details. Okay, so we are going to look at a topic for next week. If you want to understand Lambda functions, Lambda function is a topic that you have to practice over and over again. Use the pre-recorded video for you to make sense of it. It's not difficult, it's easily confusing, and it is something that when you see for the first time, it will get you very confused. Is there anonymous functions? So I want you to watch your pre-recorded video for that topic. It is quite elaborate in the video and contains all the details you need to know about Lambda functions. Anybody with question before we move to next week's topics? So I'm seeing a lot of people have network issues coming in and dropping out so frequently. So we'll keep the recording there, but for the purpose of those who have been in and out, we'll just revise this functions topic again, and then we will move to the other topic. Any question? Somebody was saying something?
No question.
Okay. So let's look at this functions recap again. We say in Python we create a function using a def keyword and then a name for the function. The function can take parameters or will not take parameters. We can have a function called greet, for instance, and we want it to do something. This function greet will have a pair of parentheses that is empty. The name of the function can be in all lowercase. If it is in more than one word, we can use snake case, where we use underscore to link to, but not spaces. After the name of the function call comes a pair of parentheses. In the parentheses, if the function needs to take parameters, we define them in the parentheses. If not, we put a colon and then we define what we want that function to do in the body of the function definition there. So let's say we want this to just return. We use the return statement to return something to the calling script when the program has finished executing. I want to say return hello world like this. We say we use if name equal to main to test this function. And what this does is, it's just a way to store the code that we want to run when the file is executed as a script. So here we'll say we want to print, because we use a return statement, we'll put in a print statement just to test what the greet function, when we call, will return. When you call a function, you write the function name and a pair of parentheses. If the function was defined without parameters, you keep the parentheses empty. If the function was defined with parameters, you have to supply arguments. And so when I run this, I have hello world printed, because we said it should return hello world when the function is called. So you call the function just using the function name and then a pair of parentheses. In the parentheses, specify the parameters, if any, or the arguments if there are parameters, and leave it empty if there are no parameters. Okay, we also looked at the different type of arguments we have. We say we have positional and keyword arguments. Positional arguments just means that when you supply parameters, you have to list the arguments in the order in which the parameters were specified during the function definition. And we said for this, we did an example trying to calculate the area of a trapezoid, and we said definition, area trap. And for this, we have a formula for the area of a trapezoid is a plus b over 2 times height. And I'll put this as a comment. And so when we calculate this, we need a, b, and height as the parameter. So what we mean by parameter is you are supplying all of the values that you need to execute that function. So if you are calculating a function, or if you are creating a function that gives you the sum of two numbers, you have to specify the two numbers. We do that as arguments to the function. And when we are defining that function, we specify them as parameters like this. And so we want this to return a plus b over 2 times h, just the formula we want it to return. So it will now plug in these values here. So the user, when the user calls this function, the user will supply these values to replace these placeholders, and it will return the final answer. And so when we say we want to print area of a trapezoid whose first base or top base is 2, bottom base is 3, and the height is 5, we should get 12.5 as the area if all is well, and we get 12.5. So this is positional arguments, where we specify the arguments in the order in which they were defined, a, b, h. If we change the definition and put h first, then we put b and a, the answer we'll get will now become wrong, because it uses positional arguments. And at this point, it is thinking that 5 is a, 3 is b, and 2 is height. So the answer becomes wrong. If you want to solve this, we use keyword arguments, where we say the keyword h is equal to 5. Keyword just means how this was defined, and want to say this is b is equal to 3 and a is equal to 2. At this point now, it knows what 5 is, what 3 is, and what 2 is. And so we're going to get 12.5 back, which will be the correct answer, because now it uses keyword arguments, and the order in which you specify them no longer matters. Then we also look at args and keyword args, where we said that we have a placeholder using a wildcard, the asterisk sign. If we don't know in advance the number of parameters or arguments the user will supply, we use the asterisk sign with the name of a parameter, args, or any name we want. So let's say we want something like a function called family, and we don't know how many members are in the family. We can use asterisk and args, and when we want to say return, args. So what we want to return are the members of the family. So we'll print, let's say family, and now in this family we are going to specify different names. Let's say Jane, John. And when we have another family, we'll print family, Jane. Let's put this as James, Joseph, and Jill. So when we run this, we have two families that we are printing out. The first family has two members, Jane and John. Second has James, Joseph, and Jill. And we'll have them printed like this as a tuple. Now, the reason for this is if we have to create a function that takes its arguments from the database, and we don't know in advance what it is because it depends on different user inputs. This is where this comes handy, and this is what you will always use in your software development. You don't know in advance the number of arguments, you use an asterisk and a name for the parameter, and when you supply the arguments, you can have all limited number of names or lists of the arguments, and the system will take it because you've told the parameter that I don't know the number, take any number the user supplies. For keyword arguments, you put two asterisk sign and keyword args like this, which means that you don't know in advance the number of keyword args the user will supply. We want to return keyword args, which means that I will do something like first name is equal to Jane. Let's say last name is equal to John. I don't know in advance how many keyword arguments. But what I say, this is first name is equal to James. I have middle name is equal to Joseph, and last name is equal to Jill. So this takes endless number of keyword arguments according to the different users. And when we run this, we'll have the keyword arguments. Want to print out everything that was specified: first name Jane, last name John, first name James. So it prints out as a key value pair of the keyword and the value. Okay. Any question? Sometimes when we define functions, we want to have a default value in case if somebody doesn't provide the value. Let's say, for instance, we're creating a function that maybe collects information about people, and we want this to be residential people. So we have country to be the default of the current country. So for us to be able to achieve this, we have something we call default function parameter. When we say, for instance, we want to say dev, let's say members, for instance, and here we want to have a default one for, let's say, country equal to, let's say, USA. This will be the default value for country. So if the user never enters a value for country, it will give you a default as USA. So I want to say return members are from country like this. And so when I print out this and I say print member India, and if I put print members without writing India, the first print statement will print. The first print statement is going to print India as the country. The second will print USA because it's a default if no country is specified. And so when I run, I will have members are from India, the other one members are from USA. So when you have default parameter value here, what we are going to have is when it's not specified, it uses the default value. When specified, it uses the specified value. Okay? So for those that will move on to course 3, the advanced Python and production development, you are going to look at function in an even more deeper method than this. This just touches all of the basic things about function you need to know, and everything you meet on technical interviews. You need to watch this pre-recorded or the recordings of this video, your pre-recorded video, to get the basic, and this video to go further in extending your basic knowledge. Any question? So let's look at object-oriented programming, which will form our basics for all that we are actually learning and the way we are going to develop our software in the future. So when we talk about object-oriented programming, it involves a grouping of related properties and behaviors into individual objects. And this all uses classes as a blueprint for their creation. Now, it doesn't make sense me talking about it, but if you have the definition in your head as we go along now, you will begin to understand what I mean by that. The classes we use as blueprints will allow us to define functions within them. When we define functions within classes, we call them methods. For example, we can define a class called person. Now, every individual is a person. So let's just look at a real-world way of thinking about object-oriented programming. Every individual is a person, and every person has a name. Every person has an age, a weight, a race, a complexion, and all of those characteristics. But what differs from person to person are the values of these different characteristics. And so we build this as a class. There'll be a blueprint where we say every person has all of these characteristics that we call properties, and then their values are the different things that will now differ. And so when we create objects from the class, we're creating, every time we instantiate the class, we're creating a new person. So we have this blueprint where we now begin to create objects from. So let's illustrate this and create a class called person. In Python, we create a class using the class keyword in all lowercase, and the name for the class, which starts with uppercase, and if it's more than one word name, we use the camel case. So we have a class called person like this. Now, we talk about having different attributes of a person, which we say that their values differ from person to person. Attributes like the person's name, the person's age, the person's height, the person's weight, and all of that are attributes. And we can define these attributes when we define the class. And we can say the attributes are, the values are what the user will supply when an object of this class is created. So we define a class using the class keyword, a name for the class, like this. And then we put a colon after that. We have different type of attributes that we can use. We have instance attributes and we have class attributes. But before we look at the types of attributes, let's just create a class. When we create a class, we create an initialization method we call init using a magic method. And this init will define all of the attributes of the person that we are defining. So we have said that we create it using def keyword. That is a function. Within a class, we call it a method, but it is a function. We define it exactly how we define function. Now we use the magic method init, which means that when we use anything init like this, it is called every time when we create an object of the class automatically without you doing anything else. When we do init like this, the first parameter is always self. Every time you define this, self is the first parameter you have. Then you now specify all of the attributes of the person. Now we have self, and we want to have attributes. Every person will have a name. Every person will have, let's say, a date of birth, or let's just use a sex, and every person will have a race. Then we want to define these attributes. We want to say self.name is equal to name, self.sex is equal to sex, and self.age or self.race is equal to race. Now, what does this mean? When we say self.name equal to name, it creates an attribute called name and assign the value that the user will supply as a name here to it. When we say self.sex, we create an attribute called sex. We assign the value the user will assign to it here, like this, and race. So you do this self.race and endlessly for all of the attributes that you add here in the init method. So which means that when you create an instance of the class, you can supply the name, the sex, and the race for each person when you create a new person. So the property of all person objects must have a method called init. So just memorize this. You create a class using the class keyword in all lowercase and a name for the class that starts with uppercase. The colon, and then the first method you must have is the init method. Is a when we say done that method, we have double underscore init and double underscore, and then in a pair of parentheses you have self as the first parameter and then all of the attributes of the person. So let's say this is the car, for instance, you are creating. So let's do something different. Let's say class car, and so the car has a make, a model, a year. So if you want to do house have doors, windows, number of rooms, and things like that. So the class is just a blueprint that we are going to use to create objects, and it makes it easy, object-oriented programming. And this is what we are going to use to create our softwares as we go along. So we have the init, which is the first. So the property of all person objects must have this method called init. And every time we create an object of this class, every time a new object of this class is created, this init will set the initial state of the object, and then you can give it any number of parameters you want here, but you just define them here. We always use self to define new attributes of the object. So when we instantiate the class, we create objects of the class that has different values and for the different properties. So let's see, how do we instantiate this class? So let's say we're instantiating this by saying we want to create a new variable called Jane. Now we're doing this outside the class. We've defined the class, we've defined the blueprint, we want to create objects. So Jane is an object of the person class. We put a pair of parentheses, we're calling the class name person, and we know that it should have a name, a sex, and a race. So we supply the name as Jane Doe, the sex as female, and the race as, let's say, Latinx or Latino. So we've created an object from this class person. So we can create several persons. They just have different values for their properties that we specify: name, sex, race. We can have another one we call John, and John is a person. The full name is John, let's say John Smith. The sex is, let's say, male, and the race is, let's say, Caucasian. Okay, and so we have created two different persons, Jane and John, and we've added their name, sex, and race. So when we say we create a class as a blueprint, this is what we mean. We mean that it takes attributes for each person and the values will differ. When we instantiate the class, it just means that we store it in a variable, a person, and we supply the values for the person. And so we can have 1 million persons that just uses the class as the blueprint to supply the attributes or the values of the attributes of a person class. And then when we want to access the values stored, let's say for instance we want to print the name of Jane, we'll print Jane.name, because name is the property that we're looking for. Or we want to say print Jane.race. So this is how we access it: the name of the variable that holds the object, or the name of the object that holds this class. So the name of the object Jane dot the name of the property that we want the value. So we want to see the name of Jane and the race of Jane here. And then when we do this and we run, we have the name is Jane Doe, the race is Latino. We can do the same thing to print John.race. Okay, and when we run this, we have Caucasian to print the race of John. So you will have a deeper understanding of this when we get to part 3 and we are developing our softwares. Okay, now we talked about the different type of attributes that we have. We say we have instance attributes, and then we say we have class attributes. Attributes that are created in the body of the class outside of the init method definition are called class attributes. For instance, let's say we want to have something we call status, that everybody who is created is alive. This is a class attribute. We create it in the body of the class because it's an attribute that applies to every object of that class. And so if I say John.status and Jane.status, all of them will be alive because it is the class attributes we created, and we use class attributes when every object of that class that is defined is going to have the same value. So status is alive. When I run this, I have alive for both of them. Okay, So the attributes, these instance attributes, are all of these attributes that are different for each object of the class. Class attributes are the same across people. If we want to change the value of the class attributes, for instance, we want to change the status of John from alive to dead, then we can now say something like John.status is equal to dead. And then when we say print John.status, we'll see now it is dead. And when we clear and run, we have this dead because we change it, update. So this is a scenario where, let's say we have a demographic app where you switch, somebody dies and you report death, you switch the status from, on the interface, you have a drop down menu from alive to dead and you change it to dead, and behind the hood, the backend will run this code to update John.status is equal to the value that you supplied. So when we look at the user input and you want to see what did the user supply and what do I want to send to the database, this is how you do that. Okay. So the functions defined inside the class are called instance methods, and the function and we say that this instance method takes self has the first parameter. Now we can define more functions here, and when I say we can define more functions here, I mean we can have let me delete this. Let's just do something else. We can have, apart from the init method, we call it method when it's a function defined inside of a class. Let's say we want to have a new method called introduce. So let's say def introduce. So we're creating a function here, and what we want this thing to have, every function we define inside of a class, or every method will have self as its parameter, either as the only parameter or as the first parameter. Okay, so it's just like for those coming from JavaScript, self just means you are doing something like this. Okay, so when we say self, let's say we want to return here, we want to return a format string, and we'll say we're returning self, let's say self.name, and this is a variable that will be here. So we'll say self.name is a, let's put self.sex, and is from, and let's put self.race. Like this, we want to make a statement when we call this introduce method. Then let's have another function. Let's say def age, for instance. And this one, we want to have self, and we want to have the user specify the date of birth, and we'll put it as DOB. And so we want to return, let's say return self.name is the current, or let's say year of birth instead of date of birth. So we'll say the current year, let's say 2024. I mean, there are methods for us to get the current date minus the year of birth, years old. Okay, so these are different methods that we can specify within this. And when we create object of the class, which means we are doing this outside of the class definition, so we'll do it the same way. Jane is equal to, we write the class name person, and in a pair of parentheses specify the values for all of the parameters here, or all of the different properties of this class. And so we say name is Jane Doe, sex is female, and then we have race is Latin X. We have John is person. Every time we call the person class, we are instantiating the class or creating new objects of the class. We say it is John Smith. John Smith is male, and he is, let's say, white. Okay, now we have created this. We want to print Jane.introduce. So when we say Jane.introduce, it should return this statement: the name, the sex, and the race. So when I run this, I have Jane Doe is a female and is from Latinx here. If I do John.introduce, it's going to have John Smith is a male and is from white. So this is not really a Pythonic way of writing this. We have a way we can write this instead of using the introduce method. And what this will do is that if we say, for instance, we want to print out just John, we are going to have like a reference address or an object reference and not any statements that make sense. So when I run this, we'll see main person object at this address this. But how do we solve this? Is to make this more Pythonic. And when I say that, we use the string here. Let's say we're introducing with the string representation. And what this just does when we use the string method is that we use this dunder string so that when we print out the objects of the class, we get the introduction in a totally different way. And this just gives us the string representation of an object like this. So when we say string double underscore, we only have self, just the same thing as the introduce, but we change that from having a method with a name introduce to having this string representation. And when we say print John now, it's going to print this introduction because this magic method gives us a string representation of the object. So whenever the object is called, instead of getting this reference address, we're going to get the introduction of John there. John Smith is a male and is from White. We will say print Jane, to just introduce Jane for us instead of having the object reference like that. Any question? So we have something we call inheritance. And inheritance is the process by which one class takes the attributes and the methods of another class. Now, if for instance we say, let me create a new class here. We have this class called person. We want to have a new class now, and let's say every person has a pet, for instance. So we have a new class called pet, right? And we want this pet to inherit the properties and the methods of the person class. We put a parenthesis here, and in the parenthesis we name the parent class where we are inheriting from. So class inheritance is just a process where we form a new class, which we'll call a child class, and this child class will inherit all the properties and methods of the parent class. So this pet is going to inherit every method that we've defined here and all the properties we've defined of this person class, except if we redefine them. Okay, so we'll define the class pet thus. We'll do it like this, and then we'll have the init method, which is always the first method we should have. Double underscore init. We always have self as the first parameter, and then we also have name. Let's say the pet has a name, a sex. Let's say the race of the pet is the breed, for instance. We'll do it like this. Now we can call parent the parent class, which is person, or we use super to indicate parent. So we can say person.init. So we just say super.init, name, sex, race. What this means is that take the definition of the name, the sex, and the race from the parent class here. So super just means that we're calling on the parent class, and we say .init. So instead of us to have initialize this here, we are saying that we should use the definition from the initialization of the parent class here. But let's say we have a new parameter. Let's say we have a new parameter called type, for instance, and we want to have a type of dog, the type of pet, for instance. So we can now have a class method, and let's say we have self.type or owner, but let's use type first. Self.type, and let's say the type of the pet is dog, for instance. So all the pets we're talking about here is a dog, and we want to define maybe different methods that this pet does. For instance, if we say in this class person, we have another class instance here that say a person speaks, for instance, they speak different languages. So put them as a list and say the person speaks. Every person that is going to define will speak English by default. And if we come here to say Jane.speaks .append Spanish, and when we print here Jane John.speaks, we will have English and Spanish for Jane. If we put John.speaks, it's just English because we put a default value of English for all objects of the class defined. We're printing John.speaks. Everybody speaks English. So we say Jane.speaks, append Spanish, and want to print John.speaks. And I will clear this. And let's see what John speaks. So we speak English and Spanish. So John.speaks, let's say we'll put this first. First of all, we have to not append to the main thing. So let's say John.speaks append French. Or no, just put John.speaks here. We'll print out John.speaks. And then I want you to just illustrate something. Let's print John.speaks here. And then we look at appending a new language to this. And then we'll print out Jane.speaks. So we append that they speak both English and Spanish here. So I'm illustrating this that the first time the default is English for everybody. So John speaks English, but when we appended for Jane Spanish, she speaks English and Spanish. But if we print John.speaks now, we just put both English and Spanish. So we're appending to the original instead of the person. And we're going to look at in the advanced course how we do this when we're doing our software development. But now what we're going to look at, and the reason for this illustration here is that I want to append something to the pet class here. And I want to say we want to add what the pet speaks, for instance. So for this inheritance, I want you to just see a complicated method where you can add properties that the dog has that the parent class person does not have. So let's say, we'll say super.speaks.append back. But before we append this, we want to clear it completely. So let's say super.speaks.clear. So we want to clear the languages that they have and say that the dog only barks like this. And so when we create a new instance, let's say my pet, and we say my pet is equal to, now we're calling the pet class because that's what we have. And then the pet's name that we want to have is, let's say the dog's name is Bingo. We want to have the dog is a male. And let's say the race is the breed. And then we'll say this dog is let's put a German Shepherd, and then we print my pet. When we save this and we run, we will have Bingo is a male and it's from German Shepherd, just like the introduction that we have here. So we are inheriting the methods and the properties of the parent class person for this pet class using all of this super and using the name of the parent class in the parentheses of the pet class definition. So when you watch this over and over again, you'll be able to get a depth of understanding. This is next week's lesson, and when I put in the basics of next week's lesson, the classes object-oriented programming, and you come back to watch this video, you will now have a greater depth. We are doing this in advance because we will not have any class next week. Any question? Okay, if there's no question, I'll make this video available by the end of the day or before the weekend is over. Take note that your assignment 6 is due next week, so you need to keep up the pace. And if you have any problem, chat up any of the admins on WhatsApp, book a one-on-one class for you to be able to catch up and have a deeper understanding of the topics discussed. So this is where we end this lesson. Is there any question before we end the class?
Not from my hand for now.
Okay.
Not from here as well.
All right. So in the absence of question, this is where we end this lesson. I wish you all a blessed weekend and see you all in 2 weeks.
Same to you.
Okay.
Thank you.
Thank you.
Thank you.